All right, now that we've gone through all the univariate data, plotting mechanisms that we can use, let's talk about the bivariate. Bi meaning two, variate meaning variables, right? And there's two major mechanisms, plotting ways that you can use with bivariate data, right? Like there are scatter plots. So there are scatter plots, and there are line graphs. Okay, they're pretty much the same thing, but line graphs actually connect the line, and they don't have as much data. So here's some information about scatter plots. It's best for use for large data sets and helps look for trends. You guys may remember from a couple of units back, we did some scatter plots and identified if there are three different characteristics of scatter plots, and you can go look back to all that in your notes and see. Right there, and then there's line graphs, and that's best for using a smaller data set, but not as many datas, and it helps look for changes over time. Okay. And the thing with scatter plots is it's useful if you really haven't identified if there's a relationship between the two variables, independent or dependent variables. It doesn't matter which one. You can just pick one to be X, pick one to be Y, and then figure that out. Line graphs, on the other hand, you kind of have to recognize which one is dependent upon the other variable. So let's get into some examples real quick right now about all that stuff. Let's start with something easy like line graphs. All right, so we're going to do line graphs now. Line graphs, not a line plot, a line graph. Okay, line graph, right? And in a line graph, you have an X and a Y axis, and it's not uncommon to see, and you guys have seen much of this already, that the X-axis is time, because time isn't really a controllable variable, right? This is your X, this is your Y, right? Time isn't necessarily a controllable variable. So let me find a good data set here. All right, let's see. Let me pause this and find some good data sets. Okay, so here's a random line graph thing. This is something is heating up over the amount of time that passes. Right? This shows over here. This is the temperature when they started heating this thing up, and this is the time in minutes. So it started off at 5 degrees. Started off at time 0. Started off at 5 degrees. Okay, let me go ahead and just figure out a better way to make it. So we'll do 5, 10, 20, 30, 40, 50, and 60. Maybe add some dots there. Okay, so that's my time. And then the temperature is over here, and you can see that the temperature isn't like in a nice, grid, like the same even amount of numbers, not nice clean numbers like this is. That's a pretty good indicator that the X, is your independent variable. It does what it wants, and then time is your temperature. So let's make our grid for time, or our axis for time, or temperature, excuse me, a little different. Let's see, the hottest it's gonna get is 85, so we'll put 90 like right here. Move this over a little bit, and move this over a little bit. Here we go. Yeah, so there's 90, and then let's do 80, 80, 70, 60, 50, 40, 30. You make this smaller. Like here. That works better. 30, 20, 10, and 0. And that's a, rough graph, rough axis. Let me make it skinnier so I can move it closer. And, good enough. Okay. I'll delete this. I need, where's there's, nope, that's not what I want. That's what I want. I want to select. So we'll delete this and this. Fill that back in. Black and black. All right. And maybe I'll move this over a wee bit. Like that. That works. We need to move it over down a little so that the 0 is at the 0. There we go. And then we'll make this a little cleaner. Okay, so that's all right. And this will be a 0 as well. So 0 and 0, just like on a coordinate plane. All right, so now we have our line graph template ready to line up, and at 0 minutes it was at 5. So at 0 minutes, do this in red. It was at like 5, which is like right here. Make me get a bigger dot. Here we go. It was like right here. Okay, at 10 minutes it was all the way up at 26, which is like in between 20 and 30. At 20 minutes it was all the way up to 45, which is in between 40 and 50. At 30 minutes, it was at 61. So it's like right here, like 61, like that. At 40 minutes, it was 74. So it's like that. And at 50 minutes, it's at 80. So it's like that. And at 60 minutes, it's like 85. So it's like that. Okay, and then if we're going to make a line graph, we got to connect this with lines. So let me, okay, yeah. So we'll do that. Make another line. Starts to look like it's a little linear, but then it trails off. So it looks like it might be approaching some asymptote, which is probably the temperature of whatever the heating device is. Right, but so that's what our line graph looks like in this situation. Okay, and if you break it down, you can see that it has, I only had 1, 2, 3, 4, 5, 6, 7 data points, right? It shows the trend real nice and easy, right? And you could actually label each one of these points here with the actual values. So it would show the data set numbers as well. So it shows the data set state, or the shape, the distribution of the shape, the distribution, the shape of the distribution. It shows, but you're also comparing two different variables together, so making it bivariate data. Before the other time, it was just a frequency in which you experienced a data point, right? And this is actually where your temperature was a function of time because we applied some heat to whatever this thing is. Okay, so that is a line graph. Let's go ahead and get rid of all that data. And let's go here. All right, now let's look at a scatter plot. Let me pause that and find some numbers for a scatter plot. Okay, so I finished off my y-axis, and this is in thousands of dollars. Okay, so this is the weight, and this is in the actual price in thousands of dollars. Right, it's just easier, right? 10987654 Why didn't I go past 3? Well, I don't have anything lower than $3,000. So at 1 carat, thing here. All right, so let's start plotting the information. So I had 3 or 4 stones that weighed 1 carat. And the first one was like 37. Maybe make this a little smaller. Okay, so like 37, which is like right here-ish, right? 42, which is right here, and like 4,000, which is like right here. Okay, and then we have one that's like 1.05, which is in between these two, right? So in this one, we had one of these was like 39, which is almost at 4, and then 4,500, which is like almost up here, right? And then so on and so forth, right? This one 1.06 is just a little bit more over, and it was 45. It was 45, and it's like right here, right? So this is how a scatter plot starts, and when it's all said and done, here is the digital version that came from the same source of the table, and it looks something like that, right? And so you can remember you're looking at if it's a like the type of function it models. It looks like it's modeling a linear equation, right? You can kind of do a best fit line right there, and the deviation from how far each one of these dots are, right, shows how close together the data is. And there's some information, there's some variables for that, and you go back to unit, I think it's in unit 6, talks about all that scatter plots and stuff. But from there, you can also see that it's closely, I mean, you can see it's a strong correlation or a weak correlation or a moderate correlation of the data. This is pretty tightly packed data, so it's a positive linear with a fairly strong correlation of the data. Right, so this is how you can turn the data into information. So with this graph, you could get a pretty good estimate of how much like a 1.5 carat thing should be about, like right here. You know, maybe in like a 2 carat one, you can expect it to be around here somewhere. Okay, so that's line graphs and the advantages of line graphs. Large data set helps see a nice trend with a best fit line.